Okay, we started off with a couple of expressions to simplify. These are polynomial expressions. Every x is there with a power, except for two numbers that don't have powers. Okay, now those are actually times x to the 0, because any number to the 0 is 1. So this is like 2x to the 0 minus 5x to the 0. You don't necessarily have to remember that. But these are all powers of x. Okay, all multiples of powers of x. You have 7 times the second power here. Down here you have a fourth power. And I think there's a number in front of that. I didn't see it when I copied it down. 5 in front of that. So there's an x to the fourth multiple of that. It's 5 times x to the fourth. Okay, well, in this problem, the simplification, we start by, we don't want those parentheses there. Okay, we just want straight terms written out so we can combine them. So minus this quantity, well, that's like minus 1 multiplied by all this. So minus 1 times x squared is x squared. Minus 1 times 4x is minus 4x. And minus 1 times minus 5 is plus 5. So the minus in front here just changes the sign of every one of these. And I think we understand that. And then we have 7x squared minus 3x plus 2. Well, now we can rearrange this. We've got a 7x squared and a minus x squared. So we write this is 7x squared minus x squared. It'd be a good idea to do that, even though you can do it in your head. 7x squared minus x squared gives you 6x squared. But if you write it out like this, it reinforces that you can regroup these things, and that's an important thing to remember. And then you have minus 3x minus 4x. Putting your x's together. And then you have plus 2 plus 5. And now 7x minus x squared is 6x squared. Then it's minus 7x, minus 3x negative 4x. And then 2 and 5 makes 7. And now we could actually check this. Let x be some simple number. Really simple number, just let x equal 1. It's not a bad check, although you usually want to use a little bigger number than that, 2 or 3 or negative 2, whatever. But if x is equal to 1, then this is 7 minus 3 plus 2. Well, 7 minus 3 is 4. Add 2, you get 6. And then this is going to be 1 plus 4 minus 5, which is 0. So you get 6. Now, if you come down here and let x equal 1, plug in 1, you're going to get 6. 6 times 1 squared is just 6. And then 7 times 1 is minus, well, not minus 7 times 1 is minus 7. And you add 7, you get 0 here. You get 6 down here, you get 6 up here. So remember, I can't stress this enough. We always have to do some kind of check. Because if you just write down a wrong answer and go on, well, if it's a test, you're going to lose credit. If it's an important problem, you're going to mess it up. Okay. So we always want to check, because if you check, you immediately know when you get something wrong. Okay. Now, it could be just coincidentally that x equals 1 is the one number that makes this equal to this. And for some other number, maybe they wouldn't be equal. Okay, so if you want to do a check, you probably pick a couple of numbers. But just a simple quick check, let x equal 1 and see if it works out. Okay, down here. And we're not going to do anything with these until we use the distributive law to multiply this out. Well, what's 4x times x squared? Well, that's 4x, sorry, 4x times x cubed is 4x to the fourth. And then 4 times -3 is -12. X times x is x squared. And now we have this expression. So I'm going to do the step where I put my fourth powers together that reinforce what we're doing. There are my fourth powers. I got x squared and the -6x squared and -12x squared. And then I've got a -7x. Now 5x to the fourth and 4x to the fourth is 9x to the fourth. 6x squared minus 12x squared is -6x squared. And -7x, right there's our polynomial. We can check it. If x equals 1, I'm not going to go through the calculations because I'm not going to write them out. But we're going to get 5 plus 6 minus 7, which is 5. It's not 5, 11 minus 7 is 4. Okay. Then this is -2 and this is 4. So that's -8. 4 and -8 gives us -4. Now I did that in my head, so we'll see. But now if I do this, 9x to the fourth will just be 9, minus 6x squared and -7x will be -13. 9 minus 13 is -4. That's likely correct. We don't have any obvious error here. Again, 1 is not the best number to use because there are things you can do that would be immune to the fact that all the powers are equal to 1. So you do want to use a different number. But x equals 1 is a quick check, and then you might want to do another number to be sure. Okay, well, that's pretty much everything that you needed to do for homework on the assigned section. So we can move on to the next topic. Okay, so we've got a few multiplications here. This is preliminary to understanding scientific notation. What's 100 multiplied by 3.7? Well, let's just make a little note over here. I'm not going to need too much room to do this, but let's kind of write this small. 100 times 3 means what? It means 100 plus 100 plus 100, which equals 300. Okay, so 100 times 3 is 300. 100 times 4 is what? Tell me what 100 times 4 is. Okay, so, I knew I was going to get the right answer. I just wanted to make sure everybody was awake. Okay, but that's not a question in this class. Okay, 100 times 4 is 400. So, $100 times 3.7 is between 300 and 400. That makes sense? Okay, so can you make a guess at what 100 times 3.7 might be? What number between 300 and 400 would correspond to 3.7 times 100? $100 times 3.7 is between 300 and 400. When you multiply by 1 followed by a bunch of zeros, you're going to get the same number. You're going to get a 3.7. but it's got to be between 300 and 400 because 100 times 3 is 300, 100 times 4 is 400. So it's very simple. You just repeat the 3/7. Okay. So this equals 370. Now, another way of saying this is hundred has two zeros. Okay. You take 3.7 and you move the decimal place over 2 places. Now you don't have 2 places to the right of the period, but you can get 2 places just by adding a 0 here. We take the decimal place and we move it 2 places for the 2 zeros that 100 has. And there we have the result. Okay. So try to understand all of this, and especially this rule. But understand that 100 times 3 point something has to be 300 and something. Okay. It's between 300 and 400. 3.7 is closer to 4 than it is to 3. So this is closer to 400 than it is to 300. Okay. It's a lot to digest. And I've used up a bunch of room here that I didn't expect to have to use up, but that's okay. I can rewrite these. Okay, so we have 10 million. Times 9.6. Now, 10 million times 9 is 90 million. Okay. So we'll just make a note here. So your number is going to be a little over 90 million. Now, 10 million times 10, because this is between 9 and 10, would be 100 million. And if I'd have thought I was going to explain this the way I am, and of course the way I explain it depends on what I see when I pose the problem, I probably would have chosen some number besides 9 in front here. In any case, ten times 10 is 100. Okay, so 10 million times 10 is 100 million. So your result needs to be between 90 million and 100 million. Okay, we'll make a guess on that one. Okay, so we got a very good guess here, and it's correct. Well, I'm going to write it out like this. Okay, and he's saying that if you got a 1 followed by a bunch of zeros, it's pretty easy to multiply. Okay. Now, okay, well, okay. Now, using this rule, right, it's pretty small, so I need the room. 10 million has how many zeros? Show me if you figure how many zeros you got there. No, they're not that many. There's 3 here and 3 here and 1 here, right? How many is that? Yeah. Full hand plus 2, right? Okay. There are 7 zeros. You can count them. 3, 6, 7. Okay. $10 million has 7 zeros. So we write 9.6. We've got to move our decimal 7 places. Okay. So let's see. If we move 1 place, it'd be here. We got to move 6 more. So we're going to need 6 zeros. So the decimal goes from here to here. This gives us then 9, 6, and then followed by 6 zeros. Of course, we group these zeros. I'm going to use commas. I like to use spaces because commas can get in the way when you're doing things on a computer or on a typewriter. Okay. If anybody knows what a typewriter is, it's on a keyboard. Okay. You get this, which is 96 million. Okay. So there's your rule, but here's another way of seeing it. And this shows you what's actually happening. This is a shortcut. Okay, so you probably want to think about what's actually happening here, especially if you're a little bit calculator dependent and don't really visualize multiplication. This hopefully is a little bit helpful. Okay. Now let's do okay. First of all, .8 is of course between 4 and 5. So 0.0001 times 4 and 0.001 times 5 is going to give us a way of bracketing our result. It's got to be between whatever we get here and whatever we get here. Now, can you write out what 0.00001 times 4 is and what 0.0001 times 5 is? Okay, let's now put, this is a little weird, especially if you've always used a calculator to do multiplication, okay? You want to understand what it means. So but I didn't write more zeros. But there's 4. And your conjecture is, and it's correct, is that this is 0.00004. Okay. And you can always do this. You can always write it out like this, because this number here is always going to be a single digit. Okay, it's going to be between 1 and 10, and it won't be 10. So you can always write it out or visualize writing it out. Look at what I did. It's like we both tried to do. I left out a 0 here. Okay, but you get the idea. Okay, so this is 0.00004, 0.0005. So it's between this and this. So, want to tell me, as soon as I pause, what you think this might be? So we conjecture that, well, we're between this and this, and we got a 4.8 here. If you multiply 4.8 by 1, you get 4.8. You just need to have all those zeros. Okay, so this is 0.000048. Okay. So you get the idea. If you go back and think about all this, you'll see. All right. And decide what to do with the boards. So I'm going to pull this one over. Or is it safe to pull it? Okay. I don't know if that's safe or not. This thing might be stabilizing it. Yeah, it's okay. Hang on. I'm going to live dangerously. That's still safe. Okay. Well, it's not all that safe. Keep getting away from it. Okay. So there's another way of writing these things. Well, let's do a couple more. What's 10 times 10 times 10? Okay, now some of you might be having a little trouble with 10 times 10 times 10. So erase one of my 10s. What does 10 times 10 mean? It means this, okay? Now, what do you get if you do 10? Okay, well, let's break this down. Okay, we're just going to talk this through. So I'm going to pause for a second. But you want to answer these, okay? If you're doing this from the video, you want to answer these questions. Okay, now here in class, we got this pretty easily. But let's see, I'm just going to write it out. 10 plus 10 is 20. Now 10 plus 10 plus 10 is 30. And this is pretty common knowledge, but again, you always rely on the calculator. You might not totally understand this, so let's be careful. 10 plus 10 plus 10 plus 10 then, well, that's 4 of them, that's going to be 40, and so forth. And we then go, etc. So if we add another 10, that's 50, so that's 5 tens. 6 tens is 60, 7 tens is 70, 8 tens is 80, 9 tens is 90, and what comes next? Well, we got it, it's 100, okay? So we can erase that question mark and write the answer, it's 100. Okay. I can write it out 10 times 100. I'm not going to write all my hundreds. I've written 5 of them. I got some dots in between, and I've indicated here it's 10 times 100, because that's what this means. 10 times 100 means you write 100 out 10 times and add it up. Except we want to shortcut that by using rules for multiplication. Okay, well, it means this. So let's reason it out again. Okay, so, well, we can reason it out the same as we did. A 100 and 100. Well, you got two of them, that's 200. Etc. So we reasoned it out. We went on up to, then I just asked, okay, what do you, if you have 8 times 100? Well, that's going to be 100, 100, 100, 100, 100, 100, 100, 100. 8 of them, it's 800. Okay, 9 times 100, well, that's 900. What about 10 times 100? And I was a little nervous when I asked that question but got a good answer. Just a little thought, it's 1,000. Okay. So ten times 100 is 1,000. All right. And then somebody said, so 10 times 10 times 10 would be 1,000. Bingo. That was a really good conjecture. And that shows a certain depth of understanding. And again, I make the advice, use a calculator only when you need it. And a lot of times we need it. Okay, so the conjecture is 10 times 10 times 10 equals 1,000. Because if you're multiplying 10 times 10 times 10, you got to pick 2 of them to multiply before you can multiply by the third one. Okay, so here I'm picking these 2 to multiply together. We know that 10 times 10 is 100 because it's 10 plus 10 plus 10, So it's 10, 20, 30, 40, up through 90 and 100. Okay, so that equals 10 times 100. And of course, that equals 1,000, as we just found out. Okay. Well, now, this is very good. Give you at least 2 stars for that. Okay, it's good. I put down 4 stars, so I'm tired of writing zeros, and I don't have the energy to write a bunch of stars. Okay, so consider that to be a 4-star action, a 4-star conjecture. That was very good. That's excellent. Okay, now. What about 10 times 10 times 10 times 10? Okay, excellent. We got a quick answer on this at 10,000. Yep. Okay. Well, we're going to use pattern. We know that 10 times 10 times 10 is, and I said it's 100. It's 1,000. I just brought out enough zeros. See, I'm getting tired. Okay, and not paying as much attention as I ought to. Looking at what I've written, but there it is. Okay, so we know that this is 1,000. And just to be sure, this equals 1,000 plus 1,000 plus 1,000, etc. 10 times. So you count that. Yeah. 1,000, 2,000, 3,000 on your fingers, 4,000, 5,000. And, you know, it's finally occurred to people, educators, that they shouldn't discourage counting in fingers. Okay. And that's has been discouraged in the schools. I think people are coming around to that. I mean, I counted my fingers and I was a top math student. Okay. I understood numbers by counting them on my fingers. Then I had a good memory, so I could very quickly remember, you know, what the sums and products of single digit numbers were, and then, you know, up to 20 and so forth. But counting in my fingers was my basis. So again, okay, 100. Okay, you got 100, 200, 300, 400, 500, that's 5 of them. 600, 700, 800, 900, 1,000, that's 10 of them. 10 of them, okay. Make sure I don't lose my chalk when I hold up both my hands. And that's I'm going to write it out in words. That's 10 thousands or 10,000. This 3 zeros means 1,000. Just get another 0. Okay. Okay, you're doing great. I'm going to push you a little bit. Let's see how you can do with this one. Okay, so well, let me back up. Let me get some notation here. Okay, what's 10 squared? Yeah, just got some excellent answers without even having to write it out. So 10 squared, well, that's 100. And 10 cubed is 1,000. 10 to the 4th is 10,000. Okay. So 10 squared is, yes. Now I can write 10 cubed is 10 times 100, which equals 10 hundredths, which is 1,000. 10 to the 4th is 10 times 1,000. That's 10,000. Now you might or might not know what to call it. You seem to have your vocabulary intact here, but can you write out what 10 to the 8th would have to be? Okay, now we had some excellent reasoning here. Okay, I'm really very, very pleased to see it. Okay, because reasoning was, and let me see what some people wrote down here. Okay, so I was thinking maybe the person that answered this had things written out, and I wanted to write it out the same way, but I just said, okay, that's okay. And that was 7. That's 10 times 10 is 100, times 10 is 1,000, times 10 is 100,000. Well, we skipped that one and got a wrong answer. But the reasoning was excellent. So, you know, well, let's just say that was 100,000. It isn't, it's 10,000. So we're going to be off by 1. Okay. Because, okay. And if that's 100,000, then 10 times 10 100,000 is 1,000,000. 10 of those is 10 million. 10 of those is 100 million. And 10 of those is 1 billion. And it came that quickly. Okay. So you understand thousands and millions and billions. It goes to trillions and quadrillions and quintillions and stuff like that. It just ends up being a bunch of zeros. Okay. Now I said, well, you skipped 10,000. Okay. So it really isn't 1 billion. What is it? He said, well, okay, it's 100 million. Excellent, excellent, excellent. So this is then 100 million. Now let's see what we can say here. Okay, you got 10 to the second power. How many zeros do you have? Just show me with your fingers. 2. I know you can count the zeros. Okay, 10 to the third. How many zeros? Same as the power, right? 10 to the fourth, 4 zeros. Same as the power. 10 to the eighth. Count your zeros. 3 and 6 and 2 more is 8. Right? So it's always the number of zeros. The number of zeros is always equal to the exponent. Well, that's good because it allows us to write really ugly numbers really simply. Okay. So let's take a number like, well, let's take one that should be kind of obvious. What would 480 million be if we use the 10 to the 8th? Want to conjecture an answer? Okay, so, what is this? I'm telling you that this is 4.8 times 10 to the 8th. Okay. Okay, so I'm going to say it's 4.8 times 10 to the 8th, which is 480 million. It's between 400 million and 500 million. I went ahead and put commas in here because my zeros are a little too close together, but I left the commas out here and just use spaces, okay? You'll see it both ways. You see it written either this way or this way. So it just means this is between 4 times this, which is this, and 5 times this, 5 of these, okay? It's between 400 million and 500 million. It's got to be between those. And how close is it? Well, it's a lot closer to 5 than it is to 400 million. It's 4.8 million or 480 million. Okay. Does that make sense? I think it does. Okay, well, I'm real happy with that. Now, there's more. And really, I'm just giving you an introduction to what scientific notation means and why we might want to use it. And how we might use it. Okay, there's another thing that, well, what's 10 to the negative 1? Okay, well, we're having a little trouble with this as I anticipated. A negative power, remember that a to the negative b equals what? It's 1 over a raised to the b. Okay. That rule for negative exponents, which I have used as the first rule for exponents, because it's the first rule we reasoned out about a week ago. This is 1 over 10. Okay. And 1 over 10, written as a decimal, is 0.1. And we want to notice I don't have room to write them all out, but okay, well, let's reason out this sum. Okay, so let me pause so we can talk about it. Okay, well, if we add this 10 times, well, we can reason it out. 0.1 plus 0.1 is 0.2. 0.1 plus 0.1 plus 0.1 is 0.3. Well, if we have 9 of them, it's 0.9. Now, what if we have 10 of them? Now, there's a little hump to get over, okay? And some people might have trouble with it. So let's be sure we understand it, because there's a tendency to say, well, that's 0.10. But 0.10 is the same as 0.1, so we're all the way back to 0.1 instead of building a bigger number, right? And then if I point that out, usually think about what it should be. It's not 0.1, it's 1, okay? Because this means a tenth, it does means 10 of them make 1, okay? I'm going to write it as 1.0. There's your 10 with the decimal here. Okay. So, I mean, you could write your sums as 1.2, 0.3, all the way up to 0.9, then a 10 here, but with the decimal where it belongs, okay? It's another way to think about it. All right. So what would 10 to the negative third be? First, by the rules of exponents, what do you think it would be? Okay, well, 10 to the negative third, by the rule for negative exponents, which you probably want to review. Okay. It's 1 over 10 to the third. Okay. Your negative exponent just becomes a positive exponent, but it goes in the denominator now. Okay. Well, 1 over 10 to the third, you know what 10 to the third is, it's 1,000. It's 1 over 1,000, right? Now, how would you write 1 over 1,000 as a decimal? Okay, if we got the right idea, I think maybe too many zeros. It's 0.001. Because if you have 10 of these, you get 0.01. You can count 0.001, 002, up to 009. Then you got 010, okay? So it's like 010 or just 0.01. And then out of these gives you 0.10. You get 0.01, 02 up to 0.09. Then you have 10 of them. So you got to go to 0.10 and 10. Excuse me, times 0.1 is 1, because we're talking about up here. Okay. So every time you multiply by 10, you're taking off a 0, but you want to understand why. Because it's easy to see why. You just kind of count it. Okay. Okay, so your rule, well, your open math is going to be explicit about the rules, but maybe not as explicit about what they mean and why they are what they are, because we understand what they are better if we understand why they are what they are. Okay, well, now We can do some arithmetic with scientific notation. So what if we wanted to multiply this situation a little bit, excuse me. What if we wanted to multiply 480 million by 315,000? Okay. We could do that, and of course you do that with a calculator. But if you want to think about the numbers and what they mean, we use scientific notation, which is more compact. We could write this as 4.8 times 10 to the 8th, and we've seen why, because we've done that one. Okay. And then how do we write out 315,000? Well, if you're using the video, you ought to figure out how to write that out. Pretty confident everybody in the class can. And we've only got about 6 minutes left, so we want to demonstrate this. So we're not going to take time in class to write this out, but that's going to be times. I'm going to put parentheses around this, just be careful. Okay, for reasons that are pretty straightforward, I think you'll understand. This is 3.15 times 10 to the 5th. A couple of important things to notice. This notation is a lot more compact than this notation. You don't have to keep writing out all the zeros. Okay. This tells you how many zeros, well, how many places to the right of the decimal they're going to be. Okay, well, then this equals 4.8 times 3.15 times 10 to the 8th times 10 to the 5th. Now, let's see, how am I going to do 4.8 times 3.15? I'm going to do 5 times 3.15, which is 15.75. But then I've got to take off 20% of 15.75, 2% of 4%, 15.75. I think that's going to give me something like 15.1. And 10 to the 8th times 10 to the 5th. If you use your rules for exponents, that would be 10 to the 13th, because you have 8 of them. This is like 10 times 10 times 8 times. This is like 10 times 10 times 10 times 10 times 10, 5 times. You got 8 times and 5 times, you got 13 times, and this is 10 to the 13th. Okay. Now, this isn't quite in scientific notation, because this number here out in front, when we do scientific notation, is always between 1 and 10. It's never as big as 10. So 15 isn't between 1 and 10. Well, we write this out as this is 1.51 times 10, which means, of course, 1.51 times 10 to the 1. I'm going to write the power here. And it's times 10 to the 13th. And then I'll group the multiplication of 10 to the 1 with 10 to the 13th. And by the rules for exponents, for what this means, that means 10 of them multiplied together, and then another one that makes 13 of them, 13 tens multiplied together, and then another one makes 14. Okay, there are your rules for exponents. There's your result. Now, if we want to write this out with all the zeros, it's like our decimal place went from here all the way out to here, 14 places to the right. Let's count. So make sure I did it right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. Now, if I put commas in here, let's see, that's thousands, millions, billions, trillions, 151 trillion. Okay. Now, I don't know what the world economic output is, but 151 trillion is probably greater than the output of most countries, okay? Maybe of all countries. I don't really recall. I know what our national debt is. It's around 30 trillion. So I think our national production is probably fairly close to our national debt. So I think that might be pretty close to the world production in dollars, okay? So it's just of interest. If you're talking about world economics, numbers this big start to make sense, okay? And you start having to be able to use them in a scientific notation, gives you a shortcut way to do that. Okay, well, there are more rules, but it's so important to understand how powers of 10 work and why they work the way they do, not just here's what you get when you punch it into a calculator. Here's why the rules work, okay? You remember the rules better if you know why they work. So we've set up the rules, okay? The rest of it is actually fairly easy. You've got a few more rules, like what happens if you divide these. I didn't have time to do that, okay? So make sure you understand your rules for exponents are going to be important. But rules for exponents with powers of 10 are actually easier than they are with symbols because it's always a bunch of zeros. Okay, well, I think you'll do okay with the homework. That was an excellent session. And good luck with the rest of it. We'll see how you do next time.